a parallel line. Okay. We worked out numbers where you're given a parallel line and then you're given a point on another line. Okay, you're given a line and you're given a point on another line that is parallel to the one you're given, and you're asked to find it. And we used the fact that for parallel lines, the gradient is the same. I think we looked at about 2 or 3 examples. Now today we want to look at perpendicular lines. Mr. Senjove is completing this, and we looked at perpendicular lines. Maybe as he does that, as to save time, I'm going to put another number the other side for parallel lines to be the last one. You're going to work it out by yourselves. By the time it completes, you should have finished this as well. Does it have power?
Yeah,
Because I need to extend it to the side. I don't know whether it was number 3 or 4, just continue from where it is, but I suspect it was number 4. Find the equation.
Teacher, are you writing in graph books?
No, we are not drawing, you're calculating. Where did you write the other one? Even what Mr. Senjave is doing, we just want you to deduce something. So even if you're to, you may not even draw the graph yourself. We are just using the graph to deduce something. Let me bring the laptop closer here. I hope the chalkboard is clear. So try out that number. Next 2-3 minutes, I'll be expecting answers from you. Anyone who has got an answer? Okay, let me see. Are you okay, Joanna?
Yes.
What's your answer?
My answer is y is equal to -5 out of 4x plus 15.
Plus 15. Thank you, Joanna. Mercy?
Teacher, mine is the same answer.
The same. Who else? Yes, Dab. You're still doing? Nicole, Namuli?
Y is equal to -5 out of 4x plus 3/2. I lost now. Why is it 15?
Me too.
Any other answer different from this? Namuli, you can mute yourself so that we avoid. Namuli, mute yourself. Namuli, are you there? Kindly. So Dab, you also have the same as Namuli's?
Yes.
Okay, maybe we can go through in the interest of time. So we rearrange this. 4y is equal to -5x plus 6. Then we divide through by 4. So we have y is -5 out of 4x plus 3/2. Now, Namudi and Dab, I think this is where you stopped. That is why you're giving me this answer. The answer you're giving me is the equation of the rearranged equation of what you've been given. So let's go ahead. Remember, parallel lines have the same gradient. So we are interested in the -5 out of 4. I'm going to use this other side. I remember the answer of 15. So if the gradient is -5 out of 4, I'm using y is mx plus c, and I've been given a 0.85. So I'm going to substitute for x, m, and y. When y is 5, m is -5 out of 4, times x, which is 8, then plus c. So here, by 4, we get 2. So we shall have 5 being equal to -10 plus c. So when you see the subject, you can see that C is 15. Therefore, the equation of the line we are looking for is y. I hope you can see here. Is y is equal to negative 5 out of 4 x plus 15. So Joanna's answer was the correct one. Namuli and Dav, you simply rearranged this equation and gave it to me as it is. Have you seen your mistake?
Yes, thank you.
Thank you.
So I hope even the rest who chose not to share their answers with us have seen what we do. Rearrange this one in the form y is mx plus c. And then we make the coefficient here, we make sure it is 1. And then we can now pick whatever the coefficient of x is our gradient. And since we are told the lines are parallel, the line we are looking for also has that same gradient. So we use y is mx plus c. We've been given the point, that line we are finding passes through the point 8, 5. So when y is 5, substitute for m, substitute for x for us to find c. Then after that, you can write the equation of that line. Mr. Senyawe is almost completing. Can I give them another number? Oh, yes. Okay. Can I have questions, if any, because we want to move to perpendicular lines? If you have a question, kindly put up your hand. Karen?
Excuse me, teacher.
Yes.
Why do you have to find the C again? Like if it's already there.
No, this C is for, now read the question. Find the equation of a line that is parallel to the line whose equation is this. We are given this line, right? We are supposed to find the equation of another line that is parallel to this one which you're given. So what we did first here was to try and rearrange. Remember we said you only pick the gradient if the coefficient of y here is 1. Actually, the first thing you do is to write the equation in the form y is mx plus c. That is the general equation of the line. That is what I did here. The first thing I did here was to take the 5x the other side, so it became a negative. Then next, I have to make sure that the coefficient of y here remains 1, and I do that by dividing through by 4 throughout. So this is what I get. Now, Karen and any other person who may be confused, this equation is still this one that we were given. I've simply written it in the format y is mx plus c. So can you mute whoever is not muted? We are getting echoes. So last time we discovered that parallel lines have the same gradient. So this is the gradient of the first line, L1. If this is L1, this is its gradient. I'm required to find the equation of another line that is parallel to this one. So their connection is the gradient and it must be the same. But I'm told that that other line I'm supposed to find passes through the point 8, 5. So I have its gradient as negative 5 over 4, and it passes through 8, 5. So I need to find the new line. Karen and the rest, the 3 over 2 is the C for this line that was already given. I simply rearrange. Karen, have I answered your questions? Let's back to this.
Yes.
Yes? Okay.
Yes.
And Mbabas.
Teacher, in relation to the first person's question, so
Yes.
you're saying that some numbers can have different equations or coordinates and the same gradient.
Parallel lines.
Okay.
Parallel lines. If I have 2 lines that are parallel, the gradient will always be the same. But the y-intercept will be different. Remember, C is the y-intercept. They cut the y-axis at different points, but they are parallel in nature. For example, if that was the y-axis, I don't know whether you're seeing. if I had just that graph, I have these two lines are parallel. The gradient, just remember this, we said the gradient is how steep the line is. So the steepness is the same, but the C, remember the C is where they cut the y-axis. So the C are different. They cut the y-axis at different points, but the steepness is the same. Rowan, have I answered your question?
Yes, teacher. Thank you.
Okay, is there any other hand up? I think those were the only two hands up. And now I want us to, we are shifting now from parallel to perpendicular. The last call for any question on parallel lines. If there's any question, kindly put up your hand. Because we are now moving to perpendicular lines. What is special about perpendicular lines? Okay, Mr. Sanjay, it looks like there are no questions. Any other questions? Perpendicular line, I mean parallel lines. Is the graph clear? Can someone tell me whether the graph is clear?
It's clear.
It's clear.
Someone read the question up there. That's when I'll know you're seeing it clear.
On the same pair of axes, draw the graphs of the lines y is equal to 3x minus 2 and 3y is equal, 3y plus x is equal to 3.
Okay. Now, since we labored last time before we broke off, we did a lot of plotting. So this time we didn't have to plot with you. That is what Mr. Senjova has been doing. He has plotted these lines. And the first line here is the line y is 3x minus 2. And then the other line here is 3y plus x is equal to 3. Now, what do you notice about this angle between them? May not be very clear for you, but what does the angle, what can you estimate it to be when you use your eye? What is the angle?
90
degree angle.
degrees.
Yes, those are, yeah. So Mr. Senjove has also been very accurate. The angle there is 90 degrees. I don't know whether you can see the reading on the protractor.
Can you see this reading?
Yes, teacher.
Yes, yes, teacher.
Yes.
So we have to
What have you, which reading is that?
90 degrees.
90 degrees. So that angle is 90. Very good. Now, what do we say about what? Answer. If lines
at right angles, which other one can we use if the line is at right angles? Anything at right angles, you have done your physics.
Which other word brings about the fact of 90 degrees?
Right angle triangle.
Very beautiful.
Okay, perpendicular is the word I was looking for. Thank you very much. So it means that these lines are perpendicular. Now, like I said, you don't need to draw. We were using this for you to get to see that those lines are perpendicular. Now we are going to do something else here. And this cover. I'm picking the lines that are there. The first one was y. Is 3x minus 2.
That's supposed to copy the picture.
The question? No, I just want us to, it is supposed to bring out the idea. I'm going to tell you when to write. Okay, so the other line is 3y plus x is equal to 3. These are the two lines we've drawn. And we've agreed they are perpendicular. Now, my question is, what is the gradient for the first line, M1?
3.
3. Very good. Now, then we're going to find the gradient of the second line. And for us to do that, we definitely have to first rearrange. So I'm going to rearrange equation 2. So I'll have 3y being equal to, this becomes negative x plus 3. And we've kept saying that for us to find the gradient, this one, the coefficient must be 1. So I have to divide through by 3. And it gives me y is negative, let me put it as a third x plus 1. So my next question is, what is M2 now?
Negative 1 out of 3.
Negative 1 out of 3. My third question now, I don't know whether third or fourth. What is the relationship between M1 and M2? I have M1 as 3. Then I have M2 as negative a third. Is there any relationship you're seeing between M1 and M2?
Yes, Rihanna.
Yes.
Rihanna.
Yes.
Rihanna, is it Rihanna that has been picked? Tell us the relationship.
I think it's Tina.
Tina?
The product of
You want me to multiply?
M1 and
M1.
is negative.
Okay, gives me 3 times negative a third. What does the product give us?
Negative 1.
Negative 1. Mr. Sekaita, is there any other hand up or Ms. Sinaskum? Maybe there's another relationship someone is.
No other hand.
Okay, no other hand. Okay. Do we have questions? Are you also seeing what Tina has seen? That when I multiply M1 and M2, I get negative 1.
Yes, teacher.
Okay. So now, is there any question up to that point?
Yes, Rihanna. Rihanna. Yes, Daphne.
Teacher, so does it
Yes.
mean that if you multiply the gradient of 2 lines and the answer that you get is negative 1, that they are perpendicular?
Very good, brilliant. That is it. That is what I wanted us to deduce. I saw another hand up.
Alice.
Yes.
Equation 2,
Yes.
the one it was x, right? Yeah, I understand it becomes negative x, but then yes, like x.
I don't know that I'm picking your question, but I think your confusion is here. There's a silent one here. Negative 1x. I don't know whether that is what Mr. Sekaita, did you pick what she was asking?
No.
No, she was breaking.
Value is it?
Alice, to try to change
Maybe you
position.
type in the chat. Alice, we can't pick you. Kindly type in the chat. I hope the chat is open for them to type at least one of us.
Yes, it is open. I've been typing.
Okay. Any other hand?
Mwebaze? Mwebaze, Karin?
Karin. Okay, maybe any other?
Okay, Nembabazi.
Yeah.
Mhm.
Yeah. Are you saying that perpendicular lines, the way we know that the lines are perpendicular is by multiplying their gradients and making them -1?
Yes.
Okay.
That is the identity for perpendicular lines.
Joy
That the
Kasacha.
product of their gradients gives us -1.
Teacher, can we also say that the gradient, the gradient of the second line is the inverse of the gradient of the first line?
Yeah, that was the other one I was expecting. It is the negative reciprocal of the other. If you can see that, that is very brilliant.
That sentence.
The product of the gradients gives us -1. We can say M2. M2 is the negative reciprocal. What is the reciprocal of 3? Dab.
The reciprocal of 3
One
will
out
be
of 3.
-1 out of 3.
No. Let me work with Dab. Otherwise, when many of you are speaking, we can't understand. So Dab, what is the reciprocal of 3?
I think it will be -1 out of 3.
No, the reciprocal. Don't bring in about that. Don't bring in the negative.
Oh,
What is the reciprocal? A third. So now I'm saying for parallel lines, if you have one gradient, the gradient of the other line is the negative reciprocal of the grad of M1.
Oh, okay.
I'm going to write that question. Pick that question. Then in your own free time, you'll just get a small piece of graph paper and draw those graphs like we've drawn here. You're not doing it now during the lesson. Just pick that question. You'll draw them there. Have you picked the question?
Not yet. It's not clear.
Please pick it. It's not clear. Someone have even read it. Anita, turn off your video, please.
Dagire, raise your hand.
Yes, Nagiri.
I was just asking what the heading was.
Perpendicular lines. It in the graph. You'll just get a small piece of graph paper. Because it is from negative 6. Yes.
What if you had already get a page at the back? People can use put that and do that graph there.
Yes, it's okay.
Thank you, teacher.
Have we finished picking that question?
Yes.
Okay.
No.
So, people.
We can't see the lower coordinate.
No, you don't need to see this. You know how to plot the graphs. You're going to plot them. Just pick this question. Leave space where you're going to fix or paste your graph paper. You're going to plot on your own. Please don't copy this. We already did, before we broke off for the other online, we did exhaustively how to plot these lines. So I believe you know how to. Just pick that statement, leave space where you're going to put your graph paper, and then you can come and write down this.
Mrs. Nambali,
Yes.
a computer is saying she did not understand the graph. I don't think.
Unless you did not attend last time before we broke off. Plot
Yes,
those two
me, I
lines.
didn't attend last time.
We can't go back, unfortunately. You get one of your classmates maybe to take you through how to plot lines. But even then, in senior one, we learned how to plot those lines. So it is about revision. Go back to your senior one books. I don't know which stream you are in, but we plotted lines. And we exhaustively did it again last time. So we can't keep moving back and forth. We are sorry, Akampulira. So write even this. You begin from this side, followed by this side. And then when you're through with that, then I'm going to write something. Are we through? Have we finished writing that? Am I alone in?
Yes, teacher.
Okay, now we are going to write the other statements I've been saying.
I can't see that high.
Okay, maybe let me even make the wordings a little bigger. So those are the statements I've been making, that the product of the gradients gives us -1, or someone else also gave us the second one, which I was looking for, that the gradient of M2 is the negative reciprocal of M1. Even the vice versa is true. M1 is equal to -1 over M2. If this is okay with you, you can stick to that. If this is okay, the second one is okay with you, you can use that as well. I give you time to write as we put examples this other side. Okay, so as usual, we start with some simpler examples. So I'm going to shortly shift the camera to the other side of the blackboard. Okay. Okay, so Mrs. Chisambo is taking us through those examples. Over to you, Mrs. Chisambo. They can first write the question, I think. First move. Kindly pick that question very quickly. That is example number 1.
Have you written the example?
No.
Okay, you can write. Write very fast.
We don't have much time.
Can we move on?
Teacher.
Yes, teacher.
Okay, we have that example. They're telling us that the following are gradients of lines. In each case, state the gradient of the perpendicular lines. So we need to look at these examples. We have A, B, C, D. From what we have discussed, I don't know whether someone is able to do for us part one from what Mrs. Nampaj has been discussing. We have the condition for perpendicular lines. Is there anyone who can attempt part A? Any idea on part A?
Take 5 to be M1 and then find M2.
Yes, Ntongo.
Yes, Ntongo.
Teacher, I think since we have M1 and we know that the product of both the gradients is -1, we can say M1 times M2 is equal to -1, and then 5 times M2 is equal to -1, and then find the other gradient.
Slowly.
Thank you. So we have M1. We can take 5 to be our M1. So we can say that M1 is 5, but we want to find M2. The condition that Mrs. Nampaj has just written, it is that M1 times M2 is equal to -1. So if I have M1 as 5, I'm going to multiply that by M2, and my answer is -1. So if I'm interested in M2, then I'm going to divide both sides by 5. And my M2 is going to be equal to -1 out of 5. And I think that's what Ntongo has told us. Thank you, Ntongo. Any other question about finding the gradient of the perpendicular lines? So can we try part B? Or can we try the rest? You first do part B. We have -4 here. Let us find the gradient of the perpendicular line. Yes, I give you 1 minute. Johanna, are you okay?
Oh, I just submitting. I thought I should give an answer.
Yes, you can give your answer, please.
I got M2 as 1 out of 4, a quarter.
A quarter. Thank you. So we have that answer. A quarter. I don't know whether someone has a question to ask. So for part B, we have,
There's another ratio percent.
M1 is -4. So we are interested in M2, but we know that M1 times M2, we get -1. So if I have -4 times M2, I'll get -1. So I divide both sides by -4, and M2 is equal to...
Teacher, we can't see the writing.
So we can't see the board.
Yes, so when you divide, here we shall get M2 as -1 divided by -4, we shall get a quarter. And that's what she told us. So there are some other hands.
Teacher.
Yes.
So is that line perpendicular?
Sorry?
Teacher, so when you get this answer, does it confirm that it's perpendicular or not?
These are perpendicular lines. Okay?
Oh.
They are perpendicular lines. So we are finding the gradient. Already we have gradient of one line. So we want to find the gradient of the second line. In this case, part A, the first line has gradient 5. So we are looking for gradient of the perpendicular line, which is the second line, even part B. So we are going to do the same thing for part C and D. Here we have fractions.
Has a question.
Yes.
Peter, I was wondering if you want to like do the method of reciprocal, do you just know the reciprocal or there's a method of finding it?
If you know the reciprocal, in fact, you don't need to go through all these.
Yes.
Once you know that if I have 5, then I need a negative reciprocal. Then you state your answer as negative 1 out of 5. The same will apply to part B. So if you know that, you don't need to go through this. Otherwise, the standard way of finding the gradient of those perpendicular lines is this one.
Thank you.
Someone inboxed me and asked me, how do we know whether it is gradient 1 or gradient 2? It doesn't matter. Any can be the first one and the other one can be the next one. But since we've been given this, it would be funny giving it M2 and then we are looking for M1. But in any case, it doesn't matter. There is no specific, this must be gradient 1, the other one must be gradient 2, either or. Someone was asking.
No, can I give the answer for part C?
Okay. Yes.
I'm not sure, teacher, but I think it's 3 out of 2.
Thank you.
Let's wait for another one. Thank you, Dad. Any other answer?
Any other answer?
Yes, teacher, I also have 3 out of 2.
So for part C, our answer is 3 out of 2.
Ronila? Ronila?
Akampulira.
Yes, Akampulira. Your hand is up. You want to say something? Okay, studying for probably you can continue and confirm that answer.
So for part C, we said we can just let M1 to be -2 out of 3. So we are looking for the gradient of the perpendicular line, which is M2. So we don't know M2, so we can say that M1 times M2 is equal to -1. So if our M1 is -2 out of 3 times M2, this is equal to -1. So we are interested in M2. Let me write it here. We have that -2 out of 3, M2 is equal to -1. So we can cross multiply. We can say -2 out of 3, M2 times 3 is equal to -1 times 3. So this 3 will cancel with that. We shall have 2M2 is equal to -3. So when we divide by -2, -2, we shall find that our M2, I hope people can see down. So our M2 is equal to 3 out of 2. So that is right. Someone gave that answer. I don't know whether.
No, you can't sit down.
Yes, I've written it up here. M2. M2 is 3 out of 2.
Where's that teacher?
Where is it? Internet issues.
It is an internet problem, please. But it's connecting soon.
Just be patient. We have 4 minutes. You
Okay,
can ask,
students, Mr. Senjabe's laptop has gone off. You should be tapping mine now. The video should be on.
Yes.
Well, part G, I hope Your answers are ready.
Mr. Sekaita, can you see us?
Yeah, I can see.
Teacher, can I answer part D?
Mr. Sekaita.
Yeah, it is.
Muted.
Yeah.
Yes, Chacha, we can see your screen.
Okay. Can you see the blackboard? Okay, yes. Yeah. Hope your hand is up. You want to give an answer?
Yeah, for part D, right?
Yes, part D.
I got 3 out of 11.
3 out of 11. Any other
I got
answer?
3 out of 13.
3 out
3
of
out of 13.
3 out of 13.
3 out of 8.
3 out of 8.
Can I got 3 out of 13?
3 out of
The answer
11.
is 3 out of 13.
Find out the correct answer, but thank you for you all trying out.
Okay, let us do it very fast. Yes, we have M1 is -4 and a third. Now the best way would be to convert this mixed fraction into an improper fraction, which gives
13 out of 3.
13 out of 3.
13 out of 3. Are we able to see that?
Yes.
Okay, so if you convert, then we shall have our M1 times M2 is equal to -1. And we have our M1 as -13 out of 3 times M2 is equal to -1. Then we cross multiply. We shall have -13 out of 3 times M2 is equal to -1. Rather, we multiply times 3 here, even this side, we multiply by 3. Okay, so we can leave it like that. So we shall have that -13 M2 is equal to -3. Then we divide by -13 by -13. So this will cancel. We shall have M2 is equal to 3 out of 13.
So those who got 3 out of 11 and 3 out of 8, I hope you've seen where you made the mistake.
So the gradient of that perpendicular line is 3 out of 13.
Any questions? It is a minute to time.
We have 1 minute. If you have a question.
I think, Sergeant, what we are going to do, okay. What we are going to do, we are going to give you, let's give them the numbers.
Javi,
Yes?
there is something in the chat. When someone is converting a fraction, she's asking,
Yes.
isn't the times -12? So you're looking at it as -12.
Yeah, I think she has failed to, she has forgotten, not failed, she has forgotten how to convert into improper fraction.
When you're changing it to an improper fraction, it's denominator times the whole number plus the numerator.
So you leave out the negative completely.
Ah, she's worried. Okay. I wasn't seeing what was confusing. Please, you leave out the negative. It is 4 times 3, which is 12 plus 1. So it is negative of what you've converted. Okay, now I understand why they were getting different answers. So thank you, Mr. Sekaita. Give them other numbers. We have. Any other questions as we write take home? Yes, Shona?
Yes, Cha. I was a little confused that on -13 out of 3, isn't the whole fraction negative, like as with 3 as well? but I saw that when
We
you
write the negative only once. We can't put negative up and down. It is either up or down, but we prefer putting it down. We prefer putting it, we prefer putting it up. So how does that change? I don't know how that affects our answers. Shona, do you think our answers will be affected?
No.
Okay, so we put, let me erase this one here. Since it is already time, we've given you numbers to try out. I hope they are clear.
You can try out these numbers on your own.
Just a guidance where you have the decimal, kindly change it to fraction. Let me guide it directly from here. Where you have decimals, kindly change it to fraction. Unless there's another question, I think we can get a closing prayer. Anyone to give us a closing prayer?
Yes, Nasuna. Leila.
Let's humble ourselves for a word of prayer. Oh Lord Jesus Christ, one, thank you for this day, and thank you for the gift of teachers and education. We pray that whatever we have learned may help us in the future, and please guide us as we are going to continue through other lessons. In Jesus' name I've prayed. Amen.
Amen.
Amen. Have a good day.
Your teacher.
Bye.
Bye. Bye. I hope you've picked those questions.
Bye.
Thank you, teacher.
Bye.
Bye.
Have a nice day, teacher. Thank you for listening.
Bye, teacher.
Bye.
Wait,